All right, students, Miss Slyman here again. Now we're looking at an example of inequalities and absolute value graphing. And in this case, we've got a system. So just like our systems from before, we want all the solutions that are going to make this true. And for sure, we're going to have multiple solutions this time because we're looking at inequalities, which means that there's going to be a whole range of values. So we want all the points x and y that are on this grid that satisfy both of these equations. And so, of course, we could start just by picking random points and checking if they're true. For example, if I took 0, 0, so 0 minus 3 is less than 0, that's true. 0 plus 0 is greater than negative 6, that's true. So my point 0, 0 is going to be a solution. It's one of my solutions. It's going to be part of a shaded area. But I don't want to just guess and check, especially with something complicated like this. So I want to try to graph this. So I'm going to turn both of these equations into slope-intercept form. So looking at that first equation, y minus x minus 3 less than or equal to 0, that's the same as y being less than or equal to x plus 3. So I want all the y values that are less than the value created by x plus 3. So I'm looking for all the points where that's true. Well, I know the equals, if I think about that part first, y equals x plus 3, that's a line that has a slope of 1 and a y-intercept of 3. So let's go up and graph that. 1, 2, 3. And then a slope of 1, I'm going to go over 1, up 1. And here's where I really wish that Notability included some sort of line tool because it's hard to draw a straight line without a ruler, but that seems okay. And I can make this line solid because I do want all the equal to values. And now I also want all the y's that are going to be less than that. So less than, if I have my y on the left-hand side and I've got a less than sign, I can think of everything being below. So I also want all of the values, so I'm just going to continue this line to the end. I'm thinking for that first equation, I want all of these values, but of course that's not going to be my entire solution because it also has to fit with my second condition. Oops. So these points, all of those infinite points, satisfy this, but I also need the points to satisfy this equation. So I'm going to switch to another color. Let's go with red. So I'm going to start again by isolating. So 3y greater than negative 2x minus 6. So I pulled my 2x to the other side. Divide by 3. Y is greater than negative 2/3 x minus 2. Notice this sign didn't have to switch because I divided by a positive. It doesn't matter that these two numbers are negative. So I've got a y-intercept of negative 2 and a slope of negative 2/3. So y-intercept of negative 2 and a slope of negative 2/3. And I'm going to make this an open circle because it says only greater than, not greater than or equal to. So slope of negative 2/3 down to over 1, 2, 3. Hard to see with my blue shading in there. Again, open circle. Down to 1, 2, 3, open circle. I could go the opposite way, up 2, over 3, open circle. So notice all these points had been shaded in blue. They're no longer valid because I don't have an equal to. Up 2 to the left 3. And I can continue this pattern and connect these, and I'm going to connect them with a dotted line to show that they're not part of the solution. The points that are part of the solution, though, are going to be above because I've got greater than. So for my red equation, here's my solution. Well, the points for the whole system, though, are only when those two things overlap. So the points for our system, I'm going to make purple. All of these points are included because that was an equal to line and they're part of the red. All of these points are not included. And then here in the area shared are the points that are that will make both equations true. So let's just pick a random one. Let's pick the point 10, 2. So that should be a solution for both, and I'm going to test it. So 2 minus 10 minus 3, that is a negative number. It is less than or equal to 0. And then 20 plus 12 is greater than negative 6. That's also true. That gives me just a quick way of knowing whether I've gotten things on the right track or not. So this was solving by hand. I'm going to stop this and I'm going to make a video showing you what it looks like on your calculator.